At 13:47 hours, 18 Russian armored vehicles raced down a muddy dirt road near Konstantinivka, pushing towards their jumping-off point for tomorrow's attack. The column commander had timed it perfectly. Heavy rain had grounded Ukrainian drones all morning, but unknown to the Russians, 3 Ukrainian drone teams had been watching the weather radar for hours, and the storm cell was breaking up faster than anyone predicted. In a matter of minutes, clear skies would turn a safe road march into a devastating ambush. 3 Ukrainian drone teams scrambled into action as 24 FPV drones powered up simultaneously across their concealed positions, motor spinning from idle to maximum RPM into seconds. The sudden break in weather meant visibility jumped from 200 meters to 2 kilometers instantly. The Russian column was clearly visible, their single-file formation stretching for 100 meters along the muddy road with just 10 minutes remaining before they had reached the concrete structures of an abandoned collective farm. If they died there, those tanks would wreak havoc tomorrow. The column had to be stopped now. However, the instant those drones transmitted their first control signals, Russian detection systems locked on, and nearby Russian SR-VSS-5 electronic warfare array identified the emissions in 0.3 seconds. Control signals broadcasting on standard FPV frequencies lit up their screens like flares in the electromagnetic spectrum. Within 8 kilometers range, the system triangulated the Ukrainian positions to within 25 meters, accurate enough for precision artillery strikes that could eliminate the operators before their drones ever reached the target. The data flowed instantly through encrypted channels to artillery batteries positioned 12 kilometers behind the advancing column. Gun crews already loading across local guided rounds. Each drone climbed fast through dissipating rain clouds, racing to gain altitude before the Russians could react. But gaining altitude meant exposing their signals above terrain masking, the area where the radar returns are naturally blocked by ground fetchers, and the Russian Orlan-30 reconnaissance drone circling at 2,000 meters. Its camera pod swung toward the launch signatures, infrared sensors picking up heat blooms from the operator's equipment despite their thermal blankets, data linking precise coordinates back to waiting artillery tubes. The Orlan-30 was able to do this because its gimbal-mounted laser designator painted targets with a coated infrared beam that Fresno rounds could home in on during their terminal phase. The drone would maintain the laser entrejet for the shell's entire 30-second on-flight time, adjusting for wind drift and target movement. This data synchronized with the Zuperk M1's calculations through the Russian tactical network. The radar provided initial firing solutions, while the Orlan provided terminal guidance. Together, they created a targeting chain that could put a 150 mm shell within 2 meters of a target at 15 kilometers.
Range. Without the Orleans laser guidance, conventional artillery at this distance would scatter across a 50-meter cycle. Good enough for area targets, but useless against individual bunkers. The lead Ukrainian team watched the tactical display as the Russians' Apark M1 counter-battery radar painted their position with increasing precision. The system worked by measuring the time difference of signal arrival at 3 separate receivers spread across the battlefield. When a drone transmitted, each receiver logged the exact microsecond the signal arrived. Since radio waves travel at light speed, even Nancon differences revealed distance variations. 3. Receivers created intersecting lines that pinpointed the transmission source like a mathematical crosshair. In 90 seconds, Krasnopo-guided artillery rounds would impact with enough explosive power to collapse any bunker not built from reinforced concrete. And these positions were just earth and timber. The stakes for the first Ukrainian team were simple: hand off control and run or get blasted. They initiated transfer procedures to the second team while Kresna Browns were already in flight. 150 mm shells with laser seekers that could adjust trajectory in the final seconds of flight to follow the Orleans designation. 8 drones under their control switched to GPS waypoint following, a 3-second vulnerability window where the drones flew blind while control frequencies synchronized with the new operators 800 meters away. 3 seconds at 140 km/h meant 116 meters of unguided flight where anything could happen. If the handoff failed, then those 8 drones would fly straight into the ground or off course, reducing the attack force by a third before it even began. The handoff completed with a half-second to spare as the first team sprinted through wheat stubble carrying 20 kilograms equipment bags. Then behind them, their bunker erupted as shells found their mark 45 seconds after they left. On the Russian side, the column's BMPT Terminator vehicles were tracking multiple air contacts. These specialized vehicles pack dual 30mm Audic cannons, AG-17D grenade launchers with 300 rounds each, and for Attica anti-tank missiles. Enough firepower to create an anti-drone umbrella over the entire column. Their turrets elevated as drone signatures populated threat displays. The second team now controlled 16 drones. Double the electromagnetic signature impossible to miss. The Orlan 30 overhead locked their position with its infrared laser, while the SERV-SS5 detected the 300-millisecond spike when both operators transmitted during takeoff. 10 meters accuracy instead of 25. They had 90 seconds before Kranoble rounds arrived. Artillery rounds were already walking toward them. The first impacted 200 meters away, throwing dirt into the air. The operators kept their hands steady on the controls despite the ground shaking. 16 drone feeds flickered across their screens, each one racing toward the Russian column at 140 kmh. The math was
simple: 45 seconds for Russian guns to recalculate, 30 for rounds to fly, but only 1.5 seconds to transfer control if needed. The third team watched their frequency scanners, systems powered, ready to grab control the instant team just started running. Another shell hit closer, 150 meters. Now the operators could feel the concussion in their chest. They initiated the handoff sequence while simultaneously grabbing their critical gear. No time for anything else. 24 drones converged from 3 launch sites, creating an immediate airspace problem. At 140 kmh, drones from different positions would reach the same point simultaneously, plastic confetti if they collided. Team 1's drones at 150 meters altitude from the northwest. Team 2's at 180 from the northeast. Team 3's at 120 from the south. 5 seconds separation at the 2 km mark. The operators couldn't see each other's drones through the static. They could only trust the choreography they practiced. The approaching storm cell was now visible. A wall of rain advancing at 30 kmh. Lightning flickered within it, each strike an electromagnetic pulse that could scramble control signals for minutes until it arrived. Battery levels at 60%. One attack run, no second chances. The Russian column was 2 kilometers away and closing. Artillery rounds now bracketed second team's position. Each impact closer than the last as Russian gunners walked their fire onto the target. The operators had 20 seconds before rounds would land directly on their position. They initiated handoff to the third team while simultaneously gathering their most critical equipment, the backup tablets that could resume control if needed. Everything else, sleeping bags, rations, personal items, stayed behind. The third team smoothly accepted control of all 24 drones, their systems managing maximum load while the second team sprinted through parallel furrows in the wheat field, using the micro-terrain for whatever cover it provided. 24 drones converging from 3 launch sites created an immediate airspace problem that could destroy the attack before the Russians fired a shot. At 140 km/h closure rate, drones launched from different positions would reach the same airspace simultaneously, and two racing quads colliding meant both turned into plastic confetti. The teams had practiced this convergence for weeks. Team 1's drones would approach at 150 meters altitude from the northwest. Team 2's at 180 meters from the northwest. Team 3's at 120 meters from the south. Each team had specific timing gates. Team 1 would reach the 2 kilometers mark at -45 seconds. Team 2 at